Hey guys, Dan the Mustang Doctor, and I just wanted to come to you guys tonight and talk a little bit about speed density tuning and just how much is really involved in tuning for speed density versus mass airflow. And what we're looking at right here is just a 2000 or a Gen 3, really 2019 Ford F-150 with a 5-liter Coyote engine. And these actually don't have a mass airflow sensor. So that's the challenging piece when you get to one of these trucks. A lot of times guys think, oh, it's just the same as the Mustang. I can tune that truck, no problem. But the flip side of that problem is a lot of guys don't know how to tune on speed density, and that becomes a challenge because there's no way to tune around that. A lot of these cars or trucks have both a mass airflow sensor, and a MAP sensor. And then a majority even just have a MAF sensor, and a lot of guys can tune on MAF because it's fairly simple. But when it comes to speed density, I just wanted to kind of step you guys through tonight the lengths of depth in tuning one of these vehicles for speed density, because there is a lot in here. And what we're looking at right now is a PCM Tech multi-tune F-150 for speed density, and we're just literally right in the speed density section of the tune. And right now we're just looking at map point 0 for quadratic term to estimate the manifold pressure with the IMRCs closed. So up here are all the variables that we're adjusting in the tune. And you can see these numbers are quite involved. They're quite long. Some are negative. Some in here you're going to find are positive, and some are just straight ones. So it is a really tricky, challenging type of tune. And there's a lot of calculators in some of the software that help make that a little bit easier. But what happens is you really got to start with the data log, and you've got to build out the data log appropriately to have the right channels. We call it an HP tuners, or just points, I guess, in SET or PCM Tech. When you're tuning or when you're data logging, because you got to be able to read from the car what these variables are producing, what the car is producing for variables in these different map points and in these different sections. And so for speed density, I'm going to flip over to SET for a second because it's a little bit easier to follow in SET because they kind of break it down per section, really. If you guys can see me over here on the side, over here we've got the offset for map and versus air charge, and then we've got the quadratic term of map versus air charge, which is what I just was describing in PCM Tech. You've got the slope and blow through region of the map, and basically what this is, we've also got the slope of map versus air charge for the closed IMRC tables. And one of the things that makes it the most challenging, I think, with Ford and the Coyote is they use a whole bunch of map points. So each one of these map points all correlate. So you've got map point 1 or table 1 for slope. You've got it for slope and blow through. You've got map point 1 in quadratic term of the map estimation in manifold pressure. And you've got the offset of map versus air charge closed IMRC map point 1. So I'm just going to move this over for a second so you guys can see this, but it's basically got all of the different map points right here per section, and this is all in speed density. Some of these you don't mess with. We don't usually make any adjustments for max load, just depending on the application or what we're trying to tune for. But really a lot of the changes are going to be down in here in these, I think it's 4 or 5 quadrants is what I'll call it. And you guys can see we've already made a few changes in here, highlighted different than black. And so these are the reason why some of these changes we have just near the bottom are because this particular tune, we're just getting into it, and we really haven't gotten into any harder acceleration or any wide open throttle adjustments, which again, for wide open throttle, we're still going to jump back to fuel enrichment tables. But for transient driving, you got to tune in the speed density tables, and these are all in correlation per quadrant, I'll call it, and relative to the map point. So not going to get into grave detail on how this works because we could spend probably days and days in here talking about this, but just to give you guys kind of a deep, high-level deep dive into how much is involved in tuning one of these cars for for MAP. And speed density versus mass airflow, it's not really the same concept at all. It's very different, and it requires a lot of math and a lot of calculations and adjustment and a lot of data logging. So really what the Ford Coyote logic is doing is it's making a lot of predictions and a lot of estimations for airflow and mass. And it's making those estimations on the fly really, really fast, which makes it extremely accurate. The challenge is getting the tune accurate and getting dialed in mathematically to, as you guys can see, some very specific data. So again, for speed density, it's a totally different ball game. If you guys have questions or thoughts or comments, feel free to leave them below. But just wanted to kind of point out a real high level, slightly deeper dive into it. And in some of the videos coming up, we'll take an even deeper dive, and I'll show you guys how the speed density calculator works, which is really, really handy in SET, and sometimes allows us to, depending on the application, allows me to go in and tune on SET or maybe even HP tuners, and then carry that information over to PCM Tech if we're working on a multi-tune. So because again, PCM Tech is the only software that has the multi-tune. So really the same concepts, just different different configuration in how they lay out the data. So in here we've got all the 4 quadrants I was just sharing, but they're all broken out by map point. So you guys can see this is map point 0. And map points 1, map points 2, and so in each one of these, they've just basically PCM Tech has taken all the quadrants and broken them out by map point instead of breaking them out by separate quadrants of all of the map points. So it does make it fairly easy to kind of carry information over if I've already tuned one in one of the other platforms, and we want to switch it over and do the multi-tune on it. But it's still very, very involved. Even just to copy that data over that's already been data logged and dialed in. So, and then one of the other interesting challenges is SET looks at it as map points 1 through 27, whereas HP tuners and PCM Tech start at 0, which is technically map point 1. So it's just a little confusing when it gets there. And then in addition to all of that, depending on what section of the tune you're in, HP tuners and SET for the most part are usually backwards or inverse of each other, and I've found that PCM Tech is kind of a blend of both. It's more correlated to SET, but it can sometimes be inverse of SET as well, so it's just tricky. But getting in and getting the right data log configuration file set up is critical for speed density tuning, and to get all of these quadratic calculations set up right, and just really get the tune dialed in. So this particular F-150 was really cool because it was one of the first ones I did with the Ghost Cam, and it sounds really, really good. But getting the speed density tables dialed in was extremely important, or this F-150 would be stalling out all the time when he came to a stop sign. So this was a lot of fun, but quite involved. So just kind of wanted to share that with you guys and kind of step through it at a high level. But if you have any questions or thoughts or comments, feel free to throw them in below in the comments. Would love to chat more about it with you guys. All right, have a good one.